Hello chemistry students, and welcome to the module 5.01 teaching lesson on the four phases of matter. Volume, and we're going to talk more about some of the details of solids here in a moment. An example would be a rock. A great example there is water. We know the difference because if you take a glass of water, it has the shape of the glass, pour it out on the countertop, it now takes the shape of the countertop. So it definitely has no definite shape, but it's the same amount of water whether it was in the cup or on the countertop. So it is a definite volume. With the gas, it has no definite shape and no definite volume. All right, the gas will take the shape and volume of the container you put it in. The example we put here is steam. So you take your gas, if you have it, say in a, bottle, and then you open it, and now it's going to fill the room, and it's going to, spread out to take the volume and shape of that room. Plasma is a fourth state of matter. In plasma, what's happened is the electrons have actually separated from the atom. This is often called ionized gas. And we'll talk a little bit here in a moment about how that can occur. A great example of that is lightning, when you see lightning. All right, so let's matter is considered a physical property. All right, remember chemical properties are properties in which you can change the substance into something new, whereas a physical property means it's the same thing. So like we take the rock for an example and we cut it in half, it's still rock, we just have two pieces of it. So that's a physical characteristic. Things like color, shape, hardness, things like that, those are physical properties. And the phase of matter or state of matter is also a physical property. The two things that affect the phases are kinetic energy of the particles and the attractive forces between them. Generally speaking, as you go down that list, they will have more kinetic energy and less attractive forces. And the attractive forces between them are called intermolecular forces, and we learned about those back in Module 3. And they do help determine the arrangement of the particles. Okay, so solid first. Again, it has definite volume and definite shape. In a solid, the intermolecular forces are very strong. That means that the particles are going to be held in fixed arrangements, and they're not free to move about, but they do vibrate in place. So it's kind of like having a bunch of people packed into an elevator. Everybody's got a fixed position. They're not able to move around, but everybody is able to wiggle in their position. But they're not able to move, say, from the front to the back and things like that. That would be a solid. They're standing in place, but they are able to wiggle. If we increase the temperature, we're going to increase the energy. Okay, remember that temperature is a measure of the average kinetic energy. So when you're doing that to a solid, what's happening is the particles are starting to vibrate more rapidly. At a certain temperature, they're going to be vibrating enough that they're actually going to be able to break that fixed arrangement. They're going to be able to overcome those intermolecular forces. That process is called melting. So, of course, as it's melting, it is changing into the next state of matter, which is the liquid. And for liquids, remember liquids again have definite volume, no definite shape. Here, remember they now have enough kinetic energy to overcome the intermolecular forces to not hold them in fixed positions. However, there's still enough intermolecular forces that they can't just run off and be by themselves. So they're still attracted to each other, but they're able to move around. So using our elevator scenario there, we still have all the atoms close together, but now they are able to flow or move around in the elevator. So now a person in the front of the elevator could move to the back, and one in the back can go front, and they are able to move around. Still close together, still have an attraction between them, but now instead of being in one position and wiggling, they're actually able to move around. So again, if we take our liquid and we continue to increase the temperature, we're again increasing the average kinetic energy. That movement or that flow is going to continue to increase. Again, at some point, we're going to get to a temperature that's hot enough, those particles have enough energy to overcome those intermolecular forces and actually separate. Now they are not only able to flow, able to move around, but now they're actually able to break all intermolecular forces and actually break away, if you will, and get away from each other. Now they can get off the elevator, so to speak, and start running off in all different directions. That process is called boiling. So of course, when we're boiling, we are now going into the next state of matter, which is the gas. Again, no definite volume and no definite shape. Out of those three, it does have high kinetic energy. And basically, as we just mentioned, there are really no intermolecular forces at this point because they are so spread out, so far away from each other that there's no real interaction between those particles. So they do move independent of each other. They just kind of do their own thing. And because they are so spread out, there's lots of empty space between them, which means they can then be compressed back together. And that is one of the properties of gases that we talk about in a later lesson. But they are compressible, which means we can simply push them together because of all that empty space. We're able to push them together. And if we push them together enough, at some point we could actually make them reconnect with their intermolecular forces and actually go back into the liquid state. Now if we continue to increase temperature, and we have to do a lot here because we got to get it to over 5,000 degrees Celsius. If we're able to get it up that hot, we of course have increased the kinetic energy tremendously, and at that point what happens is as the molecules collide with each other, they actually will knock off an electron. So an electron will break off of the atoms. Those free-flowing electrons is what we call plasma. That is our plasma state. All right, so again, basically it's just an electrically charged gas. Okay, it has extremely high temperatures. You've got electrons floating around, and of course, when you pop off an electron, you now have a positively charged atom left behind. So we've got oppositely charged particles that are floating around. So we're going to have interactions between them. Now, because of the extreme temperatures, this is not something that you just, find any place on Earth. All right, it is something that we see in some of the stars and sun, and the different reactions that are going on there. We can replicate it. For an example, in fluorescent light bulbs, we do have plasma. Of course, we mentioned earlier lightning. So there are certain moments where we do see plasma, but generally speaking, it's not something you're just going to, walk out your front door and have some plasma sitting there. You're going to have solid, liquid, and gas, but you're not going to come across plasma. All right, so of course this is a very short lesson, and we're going to build on these ideas of solid, liquid, gas, and plasma in 5.02. But for this lesson, be sure you complete all parts of the 501 tab. If you still need some help on it, feel free to attend the open tutoring sessions. There is a review sheet that you can use in the Student Resource Center. And in the Activities tab in the lesson, there is a review section that you can go through to make sure you're understanding the concepts. And this lesson does not have an assessment, so there's no quiz or anything at the end, but you will need the information as you move forward in Module 5. So thanks for joining us for the 5.01 lesson, and we will see you in 5.02.